So this is what you get once you click on arrow guidance. This is the complete setup, and this is actually a demo version. So unfortunately, if you make any changes, you won't be able to save it, because if you try to save it, it gives a, for example, I'll just give it as some name, and it will say that sorry, I'll just try to save in documents. So it will, if you try to save this, it will show that some licenses are missing because I don't have a state flow license with me. So you can't directly save this one. So you can make changes, but you can't save it. So what I did is I wrote my entire code in another Simulink. So every time I run it, I have to copy these things into this one. So I'm going to take my STK and also the clock here. Before doing that, I will just run the simulation and show how does it work. So I'm going to run this simulation. So you can see it is modeling a route for the missile, and it comes out with some graphs. So one of the important graph is this is basically an x and z coordinates of the graph. So the missile starts from here, and once it reaches over here at a particular angle from the target, it kicks on the tracking algorithm. That is how you can see the changes of that missile. And you could see, like, once it reached here, it stops. Basically they have purposefully made this stop so that the algorithm stops, and it can decide whether it had to detonate or directly fly towards the target or anything. We can change this. Rather than stopping here, I can make it fly towards target. So in order to do that, if you look at the code, you can see that there is a target position. This is the block which sends out the target, and then it goes into the algorithm. It finds out what is the current distance between the missile and the target. Then it goes to the seeker, tracker, guidance, and airframe. It's basically a very complex algorithm. If you go deeper and deeper inside, it's pretty complex. So and if you go inside the guidance loop, and there is a fuse here, because it was stopping at a distance, I can make it to go towards the target by making these changes. So I'll just stop here, and I need to bring a new model, which is this one, and I would change this so that it just doesn't stop at a particular distance from the target. So when I run this again, you could see that the missile flies towards the target, and you can see that it has went and impacted the target. So you can see that the whole simulation is x and z. There is no y coordinate, so it's in 2D. So what I'm going to do is, this is where the target is coming in, and this is the position of the missile, which is x, e, z, d. So I'm going to replace this target with the target from STK, and the missile's position at every time step is sent back to STK. So I'll delete this target, and I'm going to take my STK and the clock here, and so what you need is the simulation time of Simulink. It goes inside STK, and STK based on every time step from the clock, it chunks out the x and z coordinates. So that means this targets every time second the target is called, and if I open the reports and graph manager, x z coordinates, it will be sending out this x and z coordinates at every time step during the simulation. So STK accept it as doesn't accept MATLAB doesn't accept it as x and z individually. It goes actually as an array. So I'm going to combine both of them into one block. So I just compiled both of them into one block. So this is my x and this is my z, and this is my output, which is actually an array of x and z. I'll give this as the input here, and also the same input has to go into the output dialog as well. So I'll just connect it here, and also there is one more output which has to be given out to the workspace. I just put it here, and I just connect that to here so that it goes as an output in the onto the workspace. So in the same way, I have to do it the output as well. So in the output, I'm going to connect. I'm going to take the x and z array coming out of the MATLAB and connect it to STK x and z. But for STK to simulate, it requires x, y, and z coordinates. So the y I'm going to take, which is the target's y position, directly from the STK itself. So what is going in is my target position from STK. This will be my target, and what is coming in will be the missile point. So this missile air is actually a real time. So during the simulation, the new missile will be coming in. And another thing what I need to do is I need the simulation not to end at a particular time. So I'm going to remove this stop simulation so that it continues the simulation even after it hits the target. So this is all set. I'll close STK because STK will be open during the simulation. Before doing that, I'll just show you what is inside this code. If I double click on run STK, this is basically a MS function, level 2 MATLAB S function. So if I go on edit, you could see what is written inside. It basically calls that target aircraft. It takes out the x, y, and z coordinates, and it comes in kilometers. Because the system is designed for in meters, I have to multiply it by 1000, so that when it enters, it goes in meters. Another thing what I need to specify here is the initial point of the missile. So that is also need to be specified, which is not specified directly here but in the workspace of MATLAB. So this is the x, it's called x ini, which is basically the initial coordinate of the missile. So I have that initial coordinates. So I'll just put it here, and there is an HINI, which is basically the missile initial point. You can basically put a facility and right click and generate its Cartesian points, and you can just copy and paste that over here. So we have set the missile initial coordinates. We have our target coming from STK. This one calculates the missile position, and it goes out to STK again. So I'm going to run this simulation. So it opens up STK. It takes some time to open because you can see it's compiling, and STK takes some few minutes to open it up. So now STK has opened, the simulation has started, and you could see that this is my target coming in, and you can see the simulation time changing. and you could this was my missile initial point, and the missile has started moving, and basically it is moving towards the target. So this is actually a simulation which is pretty close by, and that is the missile air. There is some slight difference in the missile initial point here, and you can see that during every simulation step it is moving towards the target.